previous class we discussed about motion. Okay, uh, already activities about motion, how it is going on, what is meant by force, what is meant by friction, all these we discussed. And today, from today onwards, we are going to discuss interesting topic, very interesting topic, which is basing on Newton's laws of motion. Okay, Newton's laws of motion means before entering into the topic, we need to know small introduction about Galileo Galilei. Okay, Galileo Galilei. He is a scientist who introduced about. He is a scientist who introduced about um, momentum of inertia. Simply, we call it as he is a scientist who introduced about inertia. Okay, inertia. What is meant by inertia? It is a small definition. Inertia is an force which is used to turn the object either it should be motion or at rest position. Okay, we introduce this one like this. Inertia is a force which is used to turn the object either it should be in motion or at rest position. How it is introduced means by using an inclined plane. This is the inclined plane. He conducted one experiment by using inclined plane. From the inclined plane surface, he left few round stones. Okay, which means big balls. Okay, those balls are used to roll on the plane, and after some time, when it is reaching to the end of the inclined plane, they will stop at certain position. But actually, what is the definition? That object should be, when it is moving, that object should be either in motion or at rest position. For example, if we take the duster, if we keep the duster at one position, then the duster will be at rest position only. If we any external force, okay, without that force, that duster will not move. External force is required. But in this Galileo experiment, without any force, that object either try to be in rest position or it try to be in motion only. But coming to Newton, from this only Newton got an idea. Inertia is a motion, okay, it is good, but how it should be either in rest position or in motion. Then he got an idea and he explained Newton's first law of motion in this way. Newton's first law of motion or Newton's law of inertia. Okay, anything we know. This one is, we can say, Newton's first law of motion or Newton's first law of motion or Newton's law of inertia. Newton's law of inertia. Anything we can say. Okay. In Newton's law of inertia, what he mentioned, inertia means inertia. He explained inertia in this way. It is an type of force it is a type of force when the object tends to be rest position or in motion until an external force acts on it. For this, for example, if we are riding a bicycle, until we pedal the bicycle will move. Suddenly, if we apply the brake, what will happen? The bicycle will stop at certain position. So, what is happening here? A opposing force which is acting on that object, which is used to bring the object to rest position, either to be in rest position or in motion. That position is force is known as inertia. Again, inertia is derived into it was derived into three types. First one is inertia of rest. Second one is inertia of motion. Third one is inertia of direction. Inertia of direction. And coming to first one, okay, I am explaining each and everything. Coming to inertia of rest, coming to inertia of rest. Inertia of rest means the tendency of an object tries to be in rest position until an external force acts on it. External force acts on it. This is inertia of rest. Example we already given. Example means a duster is placed on a table. Duster is placed on a table, which means if I place a duster, if the duster will move only when external force acts on it. Otherwise, the duster will be in same position until it will be years or it will be months or anything. The duster will be in same position. This is about inertia of rest. Next one, inertia of motion. Same, the tendency of an object it tries to be in motion until an external force acts on it. Same, okay. Inertia of motion. So the tendency of an object tries to be in motion until an external force acts on it. For this example, you can give a moving car. Suddenly applies brake. Applies brakes. Okay. So this is about inertia of motion. Now final one is inertia of direction. Inertia of direction. In inertia of direction, we can say inertia of direction. So the tendency of an object, the tendency of an object or tendency of a body of an object to maintain its direction of motion is known as inertia of direction. For this example we can give, okay, for this example we can give as if a stone is tied to a thread. This is the stone. If we are moving the stone in circular path, so the stone will try to move in this direction only. Okay. So this is the direction of motion. For this, one more example we can give. For example, if we are moving in a straight line path, if we are moving in a car along in a straight line road, suddenly if that car took a turn, okay, left or right turn, then we will able to move either if we are moving to right side, then we will go to left side, or if we are moving to left side, then we will move to right side. Why? Because we are used to attain the straight line force, but suddenly we change the direction. So with the direction we use it to get different, which means opposite direction of the force. That is about inertia of direction. Now this is about first law, and what about second law? Simply we can say in second law how Newton's second law. In Newton's second law, simply we can say P equal to mv, which means momentum of P equal to mass into velocity. Or okay, how we are getting P equal to mv? First of all, what is meant by momentum? Today we will discuss about momentum, and in next class we are going to discuss about activities which is basing on Newton's first law, as well as what is meant by second law and what is meant by momentum, all this. Okay, so momentum means, what is meant by momentum? Momentum or linear momentum. momentum or linear momentum. Linear momentum means if we consider two balls, okay, consider two balls of m1 and m2, okay, or we can say A and B. Consider two balls of A and B. Let A be the heavier mass, A be the heavier mass, while comparing to ball B. So we can say, take it as, let A equal to m1 and B equal to m2. Here it have velocity. Here these two balls have velocity of v bar. Okay, but if we consider diagrammatically, I will tell. For example, if ball A and ball B are both are moving, this is, for example, this is ball A of mass m1 and this is ball B of mass m2. If it is moving in this direction, if it is also moving in this direction, v bar. If we are trying to stop the both balls A and B, while comparing to stop ball B, ball A requires more force. Why? Because the velocity as well as mass which is acting on ball A is more, while comparing to the velocity as well as mass on ball B. It is very less while comparing to the ball A. So that's why it requires more force to stop it. It requires very less force to stop it. This is about momentum. Okay. This is about momentum. This we can say as m1 greater than m2. m1 greater than m2. So conclusion of momentum as well as linear momentum is, conclusion you can give, conclusion, the quantity of motion, of the moving body proportional to first one is mass of the body, and second one is velocity of the body, okay. This is about momentum, and from next we are going to discuss about Newton's second law in next class, and we are going to discuss which activities which is present on first law as well as second law in next class. Just go through the inertia, types of inertia, Newton's first law. Okay, what Galilei introduced type of inertia.